This is Unit 13, Lesson 4, the unit circle. All right, so some of you have learned, or you went over the unit circle last year at the end of your pre-AP Geo class. If you came from geometry, not pre-AP, you most likely haven't. So that's okay, though. All right, so what is a unit circle? Well, it's a circle on our coordinate plane, and it's important to know that the radius of a unit circle is 1, and the center is at the origin, okay? And that's going to help us as we're moving along. So the unit circle, once again, because it's 1 unit with the radius and the center is at the origin. So we're going to use that concept to identify our trig functions based off of just a random point, and then we'll use that to help us complete the actual values in our unit circle when we look at the degrees. All right, so taking a look over here, P represents just some point on our unit circle that has the coordinates x, y. Right now, we don't know where it is. We are going to, like I said, take a look at what those coordinates will be given certain angles. But for right now, we're going to take a look at x and y. So looking at my theta right here, I can conclude that this distance is x because it's, the x distance along the x-axis, and here's my y. All right, x and y just represent some numbers. So we're going to use those values to fill in our trig functions. All right, and we know that the hypotenuse is going to be 1, and I can say that with 100% confidence because I'm telling you that the radius is 1. And the hypotenuse represents the distance from the center to the circle, so that's going to be 1 no matter where that point is. So with that being said, remember sine is going to be opposite over hypotenuse. So from this theta right here, opposite is y over the hypotenuse is 1. So the sine value of any given angle is always going to be the y coordinate of where that point corresponds on the coordinate plane. Cosine is going to be adjacent over hypotenuse. So that is x over 1, or just x. And once again, this will all tie in as we move throughout the lesson. So if right now you're not sure why I'm doing this, it will come clear as we go on. So tangent is opposite over hypotenuse, opposite over adjacent, which is y over x. Now take a look at your cosine and your sine. Something that we haven't really talked about yet, but we will need to know moving forward. Tangent really is just cosine divided by sine. Okay, and we're using this throughout trigonometry, but tangent is the same as cosine divided by sine. I don't know why I wrote tangent. All right, so in that case, it's y over x. We're going to keep that in mind. All right, and then we have our reciprocal trig functions, which literally is just the reciprocal. Don't forget cosecant is the same as 1 over sine, so it's 1 over y. Secant is the same as 1 over cosine, which is 1 over x. You need to know those, what the cosecant and what secant is. Cotangent is the reciprocal of tangent, so it's really sine over cosine. So in this case, x over y. All right, and we're going to be using this, like I said, as we move on. For right now, before we get into the nitty gritty, let's make sure we know where angles fall on our unit circle. So we're going to start by labeling our axes. So we always start, remember, here, and that's 0 degrees or 360 after you make one full rotation. So let's label by the quarter. So moving along, we're up here at 90 degrees, 180, and 360. I'm sorry, 270. What? All right, now you'll notice from there that in between each of those quadrant measures, the axis measures, we have 3 lines that represents 3 different angles, okay? We're always dealing with 30, 45, and 60. And think back to our special right triangles, that is why. Of course, there are other angles in between. However, for the unit circle, we're only going to be referencing 30, 45, and 60s, and then the angles that relate to it. So moving along, here's 30 degrees, 45, and 60. All right, now we move to the left. I've got 120, 135, and 150. Okay, moving along, so then I'm adding 30, so 210, adding 15 to that, 225, 15 to that is 240 degrees. Add 30 at 30, so 300. All right, once again, these are not the only angles on our circle, but the ones that we are going to look at, the most important ones, okay? Now remember, reference angles. All of these that are not in quadrant 1 have a reference angle. For example, what is the reference angle of 150 degrees? This is when you shout out an answer to the computer. Correct, it's 30. Because remember, for reference angles, we are always going to the nearest x-axis. So this guy has a reference angle of 30. This one has a reference angle of 45. This one has a reference angle of 60. Okay, you always refer it back to the x-axis. This one is 30, 45, 60. Okay, looking in quadrant 4, we've got, this one is this one's 30, 45, 60, because you are referring to the closest x-axis. And of course, 30, 45, 60, right? We are going to be using our reference angles as we move on. All right, now before we get there, let's figure out what these mean, or I'm sorry, what the equivalent radians measure is, all right? So let's start with what we know. One full rotation around 360 degrees is the same as 2 pi radians, okay? So 180 is half of that. Half of 2 pi is 1 pi. Now let's fill in our 90 and our 270. What's 90 degrees is half of 180, so what's half of pi? Pi over 2, or 1/2 pi. 270 is in between 180 and 360, so it's in between 1 and 2. Well, what number is in between 1 and 2? 1/2, also known as 3 pi over 2. Now, we can come up with all the radians if we just use some common sense thinking and use our reference angles. Worst case scenario, you can always use a conversion formula, absolutely no problem. But if you start to recognize patterns, it saves you time, it saves you paper, it saves you lead, and it saves you thinking skills. All right, so let's break it down from there. Let's fill in our first quadrant ones, okay? I'm going to use the same trick. I'm going to cut things in half. All right, if 90 degrees is pi over 2 and 0 degrees is 0 radians, okay, right, because 0, 0. Halfway between those, because 45 is half of that, so I'm taking half of pi over 2. So if I have pi over 2 and divide it by half, I'm really looking at pi over 4. Okay, now to find the other two, I would use my conversion formula, but let me show you something, and you would get pi over 6 and pi over 3 if you do. Those I remember from when I learned it. I remember my radians from the quadrant 1, and the reason is this. Knowing 2 pi over 2, cutting that in half for pi over 4, and then look at the 60 and the 30. What always helps me, and take this trick or leave it, it doesn't matter, but 60 degrees has a denominator 3 and 30 degrees has a denominator 6. That's how I kept them straight. I knew it was 3 and 6, and it was just kind of the flip. So for me, that helps. Take it or leave it. From there, I can fill everything else in using my reference angles. Okay, you don't have to. Once again, you can convert, but let's use the reference angles. 120, the reference angle is 60. All right, well, how many times does 60 go into 120? 2. So it's 2 times pi over 3. 2 pi over 3. 135 is the reference angle of 45. Okay, so how many times does 45 go into 135? 3 times. So it's 3 pi over 4. Let's actually go around. Let's do all the 45s. They're all the middle ones. Okay, so now I'm up to 225. So how many times does 45 go into 225? 5 times. So this is 5 pi over 4. Okay, 330. That says 335. It looks like 335. No, 330. What am I doing? Sorry, my degrees and they're all confusing me. How many times does 345 go into 330? 7. Okay, so 7 pi over 4. You notice that your pi over 4s go odd. 1, 3, 5, 7, because the others are in here. Like 270 is also 6 pi over 4, which reduces. Pi is also going to be 4 pi over 4, which reduces. So, yeah. Okay, all right, now let's take a look at our 60 degree reference angles. All right, so up here, the 120, 61 and twice. The 240 is another 60 degree reference angle, so 240 divided by 60 is 4, so that's 4 pi over 3. All right, and over here, the 300 divided by 60 is 5, so 5 pi over 3. All right, now you'll notice some of them, like I can do 240 divided by either 60 or 30. You'll get the same answer as long as you reduce. It's really not a big deal, okay? All right, so let's fill in what we're missing. 150 has a reference angle of 30. 150 divided by 30 is 5, so that's 5 pi over 6. 210 is 7 groups of 30, so that's 7 pi over 6. And the last one, 360 is... Something is wrong. I'm sorry. I knew something looked funny there. That's a 315 and a 330. All right, this one is still going to be 7 pi over 4. I knew it looked funny. Weird. Sorry. Okay, so 330 divided by 30 is 11, so that one's 11 pi over 6. Okay, you don't have to memorize these numbers, guys. It is helpful to have a general idea of what it equals. So if I'm asking you to find the trig function of a radian degree, or I'm sorry, radian measure, you can always convert it though, okay? All right, so let's move on. Let's now get into the unit circle. So let's do a quick review of our 30, 60, 90 because we need those numbers moving forward. So while I'm shrinking the window here, what I would like you to do is write down your trig ratios for those two triangles. You need to know those. That is a non-negotiable. You need to know those trig functions. All right, so what is across from the 30-degree angle? It is 1. What is across from 60? Radical 3. Across from 90 is 2. You need to know those. 45s are 1, 1, square root of 2. Okay, so we're now going to fill in the coordinates. We're going to fill in the x and y value of where that angle, what coordinate that falls on based on the angle that's given. I'll explain that further in just a minute. So let's start with our quadrantal angles. And I forgot to point that out back here. I'm sorry. Quadrantal angles are the angles on the axes, like 0, 90, 180, 270. They just have a name because they're on the quadrant axes. Okay, so looking starting right here. Remember, the radius is 1. So what are the coordinates of this point? 1, 0. All right, going up to 90. What are the coordinates of that point? 0, 1. 180 is going to be -1, 0, and 270 is 0, -1. Okay, those are whole number points. Now, we're going to find the coordinates for all of the other points, okay, using our 30, 60, 90, 45, 45, 90, because those are the angles, 30, 60, and 45, okay, and everything else refers back to that. It's a degree of it, all right? So we're going to use a triangle to fill out the first quadrant, and then we're going to use the first quadrant to fill out the rest. You can use the triangles throughout, no problem, but you're going to just keep doing the same thing over and over again. There's a pattern which I will show you. So let's look at our 30-degree angle first. So we're saying if I draw a triangle here and drop this down, okay, I want to find the x and the y coordinates. All right, how do I do that? Well, think back to what I said before. Remember on our first page back here where we were saying that, hey, sine is really just the y value. Well, this is what I'm talking about. And cosine is the x. Sine something is going to be the y value right here. The sine of 30 degrees will be my y value that I fill in. The cosine of 30 degrees is my x value. So let's jot that down. X comma y, cosine comma sine. They go in alphabetical order. Cosine then sine, x then y. Okay, so let's take a look at our triangle up top. What is the cosine of 30 degrees? Well, cosine is adjacent over hypotenuse. So this is going to be the square root of 3 over 2. All right, our sine is going to be the opposite over hypotenuse, so 1 over 2. Okay, so that point is at those coordinates, some decimals. All right, let's do the 60 degrees. We'll stick with our triangle and then we'll flip-flop. Okay, so now we're doing the 60-degree one. Okay, here's our right angle, just like that was. So we're finding out these values. All right, now, x is cosine, so let's find the cosine of 60 degrees. It's -3 over 2. Let's find the sine is 1 over 2. So notice also, if you remember back to the beginning, I pointed out, not this lesson, but back in the unit, I pointed out to you that the sine of one angle of a triangle is the cosine of the other angle. Well, look at that. The sine of 60 degrees is the cosine of, oops, hold on, something's backwards. What did I do? I switched them up. Sorry. Thank you for noticing and shouting to the computer while I didn't pay attention to you. 60 degrees, the cosine is 1 over 2. And radical 3. And I went back and said, wait a minute, those are supposed to be opposites of each other. Okay, so once again, the cosine of 60 degrees is the sine of 30, vice versa. All right, so let's look at our 45, 45, 90. So cosine and sine will be the same because they're both 45 degrees. So it's going to be 1 over radical 2. However, you cannot leave a radical in the denominator, so we need to rationalize. So we have the square root of 2 over 2 for both the cosine and the sine. All right, there's a pattern here, starting at the top, going to the bottom. 1, 2, 3. 1, 2, 3. If you can count to 3, you know your unit circle. 1, 2, 3, 1, 2, 3. The denominator is 2 for all of them, so just remember that. All right, and it's the square root of everything. But the square root of 1 is 1, so we don't have to write the radical sign. 1, 2, 3, 1, 2, 3. That's all I need. I can go ahead and fill in the rest of the unit circle, but really that is all I need. All right, let's take a look. Go into quadrant 2 now. Okay, go into quadrant 2. Start with the 120. What is the reference angle? It is 60 degrees. So go to your 60 over here and write it down. 1/2 radical 3 over 2. 135 has a reference angle of 45, which is the square root of 2 over the square root of 2. You know what I meant by that. The 150 has a reference angle of 30. Looking back in quadrant 1, 30 is radical 3 over 2, 1/2. They're the same, guys. Look, here's my pattern again, starting at the top on the left. 1, 2, 3, 1, 2, 3. I don't need to sit here and draw. I can. You can draw the right triangle every single time and figure it out. But as long as you remember those numbers, you are good to go. So what's the whole point of doing this? Well, first of all, we're going to come back to quadrant 2 in 1 minute because we need to add something. But what is the cosine of 45 degrees? At that point, you should be able to look over here and say, oh, radical 2 over 2, because I need to be able to give an exact value without a calculator. So the cosine is radical 2 over 2. I got that because I remember cosine was the x value. What is the sine of 30 degrees? It is 1/2, because it is the y value of my 30-degree angle. All right, last question. What is the tangent of 60 degrees? Dun, dun, dun. Tangent. All right, tangent, guys, remember, is sine over cosine. It's y divided by x. So it's y of 60 degrees divided by x. So I'm going to flip that fraction and reduce. So the tangent of 60 degrees is just radical 3. Okay, now you can type tan 60 in your calculator and get a decimal, and then type in square root of 3 and realize the decimals match. But you need to be able to give me an exact value without typing it in and getting a decimal on your calculator. All right, now moving back to quadrant 2, I can do the same exact thing, except let's think about our points in quadrant 2. What is true about all of the x values in quadrant 2? If you said they're negative, then you are absolutely correct. So our cosine will be negative in quadrant 2. Okay, our x values. All right, so let's take a look at quadrant 3 and let's see what's going on down here. All right, so 210, find your reference angle. 30 degrees. So go take a look at quadrant 1. 30 degrees is our radical 3 over 2, 1/2. 225, reference angle is 45, square root of 2 over 2, square root of 2 over 2. 240 has a reference angle of 60, which is our 1/2, square root of 3 over 2. Hey, look, here's our pattern, but we're going backwards. This time, starting on the left, we're going down. 3, 2, 1, 3, 2, 1. Okay, once again, going down. 3, 2, 1, going back up, 3, 2, 1. Think about it. I reflected that. Floop, I flipped it. What was up top came to the bottom. All right, reflected over the x-axis. All right, and then our last quadrant. Oh, nope, sorry, signs. What do you know about to be true about all of the points in the third quadrant? My x and my y's are negative, so everything is negative. Sine and cosine are negative. All right, last one, quadrant number 4. Okay, reference angles. The reference angle for 330 is 30, so our 30 is the radical 3 over 2, 1/2. Reference angle for 315 is 45. Square root of 2 over square root of 2 over 2. Reference angle for 100 is 60. So the 1/2 square 3 over 2. Hey, wait a minute. That's the same exact pattern that we just saw over in quadrant 3. Go top to bottom. 3, 2, 1, 3, 2, 1. Okay? So in all honesty, guys, if you just remember from quadrant 1, 1, 2, 3, 1, 2, 3, you can fill in the entire rest. Just making sure that you flip it when you move to the bottom half below the equator. Just like how the toilets spin backwards, so do the trig functions. Okay, now let's think about negative signs. In quadrant 4, x's are positive, y's are negative, so our signs are negative. All right, so let's talk about our signs. Let's make a little chart. 1, Q2, Q through 4. So what we're going to do is we're going to state where things are positive. So in quadrant 1, which of my trig functions are positive? Well, since the x value is positive, that means cosine is. Since the y value is positive, that means sine is. Tangent is y divided by x, sine divided by cosine. So positive divided by positive is positive. So all of my functions are positive in quadrant 1. All right, in quadrant 2, what's positive? Well, my cosine is not because it's negative, because the x value is negative. My y value is positive, so sine is positive. Will tangent be? No, because I'll be doing positive divided by negative. Therefore, it's not. So sine is the only one that's positive in quadrant 2. Quadrant 3, both sine and cosine are negative because x and y are, therefore they're negative. Tangent, I'm doing negative divided by negative. That's a positive, so therefore tangent is positive. And in quadrant 4, let's take a look. My cosine is positive, right, because my x value is. My sine is negative because my y value is negative. And if I try to do the tangent, it's going to be negative divided by positive, so therefore it's not. So let's sum this up. In quadrant 1, all sines are positive, all trig functions. In quadrant 2, only sine is positive. In quadrant 3, only tangent is positive. And in quadrant 4, only cosine is positive. All students take calculus. Gives you a little acronym for which signs are positive in which quadrants. That will help us as we are identifying trig functions. All students take calculus. So you do not need to sit here and memorize the entire unit circle. What you need to know is that the radius is 1, so that you can give me the points for my quadrantal angles. What you also need to know is the pattern 1, 2, 3, 1, 2, 3. From there, I should be able to fill in all the rest using reference angles, okay? 1, 2, 3, 1, 2, 3. Know those 3 and you have everything you need. And the last little piece you need to know is about your sines. Because if I tell you to find me the sine of 210, you don't have to have this whole circle drawn. You need to know the reference angle, that it has a reference angle of 30. So then you go over to your 30s. You need to know that in this quadrant, because that's where 210 is, only tangent. So when I'm asking for the sine, you better slap a negative in front of that answer. All right, let's do some practice with this. Okay, up top it says read the following scenarios and determine in which quadrant the terminal side of each angle could lie. All right, before we get started, I'm just going to write down my pertinent information. All students take calculus. And I'm going to write the information for my 60, my 45, and my 30. 1, oops, 1, let me give myself a little more room, sorry. Do it down the side. 60, 45, and 30. 1, 2, 3. Going back up, 1, 2, 3. That's all I need to know. All right, so it tells me that if the tangent is less than 0, meaning if tangent's negative and cosine is positive, which quadrant would my angle be in? Okay, well, let's think about our positives first because there's less of those. Cosine is positive in which two quadrants? Here and here. Well, in which of those options is tangent also negative? Only in quadrant 4 is it negative. So quadrant 4 is where that angle would fall. All right, and then it says if sine is negative and cosine is negative. So I'm looking for both sine and cosine are negative. The only place that will occur is down here in quadrant 3. If cosecant is positive, so cosecant is 1 over sine. So it's going to follow the sine pattern. It doesn't matter that it's a reciprocal. Wherever sine is positive, so is cosecant. Wherever sine is negative, so is cosecant. Okay, so with that being said, I'm looking for where it is positive. Sine is positive in both 1 and 2, so that means cosecant is also positive in both 1 and 2. All right, the last one, where is cosine negative and cotangent positive? Okay, so tangent is positive here and here. So which of those is cosine negative? Down here in quadrant 3. All right, so what we're going to do now is we're going to go ahead and evaluate our trig functions. So there's 3 steps. The first thing you always want to do is find a reference angle. If you need to convert it to radians and it's not a radian, you know, convert it to degrees first and then find your reference angle. That's important. The second corresponding, find the trig function, the 1/2, radical 3/2, whatever it may be. And the last thing is worry about your signs. Now, if you take time and literally draw the entire unit circle with all the signs on it, then you can just go from there. Once you have the reference angle, just find it, write it down, you're good to go. If you're just writing down the coordinates for the first quadrant, this is what you need to do. So it's kind of whatever you prefer, how much beginning work you want to put in. Okay, so let's start. Cosecant of 30 degrees. So 30 degrees is a reference angle, right? I don't need to do anything there. Cosecant is 1/sine, so I need to know that. So I'm going to look for the sine of 30 degrees. So looking up at my sine is the y value, right? X comma y, cosine comma sine. So sine is the y value, so it's 1/2. So that means it's going to be 1 divided by 1/2, which is also known as 2. All right, and my next one, it's cosine of 420 degrees. Okay, so let's figure out a reference angle. So first things first, that is more than one full turn. So I'm going to subtract 360 and then find a reference angle as needed. But when I subtract 360, I get 60 degrees, which itself is the reference angle. So I don't need to break that down any farther. Okay, so 60 degrees, I'm finding the cosine. Go up to my chart, cosine is my x value, so it's 1/2. 420, think about where it's located. It's one full turn smidge. It's in quadrant 1, therefore it's positive. All right. Sine of 135 degrees. Reference angle, 135 is 45. Hint, if it ends in a 5, the reference angle is 45. All right, so 45 degrees, and let's think about where it is when we deal with the sines. 135 is over here. It's in quadrant 2. So sine is positive. All right, so my answer will be positive. So I just need the sine of 45 degrees, which is radical 2/2. All right, tangent of 270. Okay, 270 is, I don't need the reference angle, it's a quadrantal angle, so think about where that is. That's going to be down here at 0, -1. Tangent is y over x, sine over cosine. So it's -1/0. Wait a minute, a denominator of 0 means it's undefined. There is no tangent of 270. So undefined would be your answer. Tangent of 4π/3. Okay, let's figure out what 4π/3 is. I remember that it's going to be a multiple of 60-degree angle because π/3 is 60. So it's 4 times π/60. So 4 times 60, 240. Look at that. Or just use the formula. Same thing. All right, so that's the degree, but we need to find the reference angle to it. Okay, we can think about where it is. 240 degrees is down here in quadrant 3. Okay, so if I'm finding the, I can't even read what I drew over there. Is that tangent? Whew. If I'm finding the tangent, it's too blurry. Yes, I'm finding the tangent, so therefore it's going to be positive in that quadrant, so I don't have to worry about my sign. But 240 has a reference angle of 60 degrees, 240 minus 180. So I'm finding the tangent of 60. Okay, so we got to do a little bit of work here. Tangent is y divided by x. So I'm doing the square root of 3/2 divided by 1/2. I find it easier to just write them sideways, and we're going to multiply by the reciprocal. So the square root of 3/2 times 2/1. Reduce, so it's just the square root of 3. All right, cotangent of π/4. Well, π/4, I remember, is 45 degrees. If you didn't remember, do the math. All right, but that's 45 degrees, which is the reference angle, which is in quadrant 1, so will be positive. Okay, cotangent is going to be the reciprocal of tangent. So it's no longer y over x. This time it's cosine over sine, or x over y. Okay, so looking at 45 degrees, it's going to be the square root of 2/2 divided by the square root of 2/2. Square root of 2/2 times 2 over the square root of 2, which everything reduces. All right, secant of 300 degrees. Secant is 1 over cosine. 300 degrees is here in quadrant 4, so that means all students take calculus, it's positive. 300 degrees, find our reference angle is 60. Okay, 360 minus 300, my RA reference angle is 60 degrees. So I'm looking for the secant, the cosine of 60. Let me go back up. 1/2. So you don't need to, you don't have to redo the 1, 2, 3, 3, 2, 1 every time if you just write down those three numbers. That should be enough. Okay, so cosine 60 is 1/2, but it's asking for the reciprocal, so 1 divided by 1/2, which is 2. All right, sine of, sorry, I was looking at something. Sine of 240. Okay, sine 240 is going to be here. That's going to be a negative because tangent's the only positive one in that quadrant, so my answer should be negative. So let's find our reference angle. We've done 240 before. It has a reference angle of 60 degrees. So I'm doing the sine of 60. So the y value of 60 is radical 3 over 2, but it's going to be negative because of which quadrant is located in. All right, and my last one, the cosine of 11 pi over 4. So let's change that to degrees. So I'm multiplying by 180 over pi. That's off the top of my head. It's going to be 11 times 45, whatever that is. On 45. So 5, 4, 0, 5, 4, so 495. Okay, so that's one full turnaround. So 495 minus 360 is 135. Okay, so it's 135, so it's 102. All students. Sine is the only positive one in quadrant 2, so my answer will be negative. Okay, reference angle of 35 is 45 degrees, which we got because, actually, I could have just realized that because it was pi over 4. But I did need to also know which quadrant it was in, so we had to go through and figure out the base angle. Anyways, I digress. Cosine of 45 is radical 2 over 2 because of the quadrant. Ladies and gentlemen, it is important that you study and you remember those numbers. Without them, this is going to be a challenge. Please do the practice, check your answers, and bring your questions to class.